So here are my examples for section 1.1. These are basically the same examples that you would see in class if we were having regular class. I will go kind of fast through them with the understanding that you can pause it and go back if you need to. So the first thing in section 1.1 is dealing with the coordinate system, the Cartesian coordinate system is what it's called. So the first example is just graphing points, graphing coordinate points. So if you graph point A, 3, -2, this is the x-axis, that's the y-axis. So you go over to 3, down to -2, and that's point A. Just label it with the capital A. Point B would be -3, -4. So that's going to be in the third quadrant. Okay, third quadrant is down here. This is the second quadrant. This is the first quadrant. This is the fourth quadrant. They go in Roman. They use Roman numerals. They go counterclockwise. Point C is -4, +5. So that's going to be in the second quadrant. Point D is 2, -4. So looks like I already got those labeled well enough. So that's going to be point D. And point E is one that trips people up sometimes, 0, 5. So on the x-axis, that's a 0. So we don't go left or right at all. We just stay right at the origin, and we go up 5. So that's going to be point E right there. Okay, so graphing coordinate points is the first thing in 1.1. The next example I have here is it's a yes or no question. The question is this ordered pair a solution to the given equation? So I'm giving you this equation right here, and I'm asking you if this ordered pair satisfies that equation, or if it is a solution, is another way to say it. So all you have to do is substitute in the value for x and the value for y. So remember that the first number there is our x value, the second number is our y value. So we're going to put a 2 for the y. When I do substitutions, I almost always use the parenthesis. Now this becomes a question. We don't know if they're equal or not. That's what you have to decide. So the question is, are those things equal? Does 2 equal... Oh, I screwed up on the sign. That's not a -3, it's a +3. So the x value is just a 3. So does that work out? Does 2 equal 2? Yes, that works. Okay, so it's a yes or no question. Is the ordered pair a solution? So I'll do one more here. This is -1/2. I don't like writing fractions like that, but that's how I typed it. So instead of x, I'm going to put a -1/2. And instead of y, I'll put a 2. I'll try not to screw up on the signs this time. And again, the question is yes or no. Is this thing a solution to this given equation? Or another way to ask that, does this point satisfy the given equation? And so on this one, the answer is no, it does not. -6 does not equal 6. It's a yes or no question. Okay, so that's kind of background stuff. But as far as quizzes and tests and stuff, this is the stuff you're really going to have to try to remember. How to find intercepts. Remember if you watch the other videos, the notes or whatever, read the book, the intercepts are points on a graph. So to find the x-intercept, what you do is you let y equal 0. All you have to do is pretend that this y term is not there. So if y is equal to 0, that gives us -3x equals 12. Well, we need to solve for x, so I'm going to divide by -3, and we get x equals -4. However, that's not good enough. That's not really the way you're supposed to write it. The x-intercept is a point on a graph. So when you do your quizzes and stuff, the x-intercept is supposed to be written as an ordered pair, -4, 0. And so what you'll notice is the x value is whatever we found here, over here, and then the y value is the 0. Okay, so that's our x-intercept. We also have to find the y-intercept. Well, the y-intercept is found by replacing the x with a 0. So to find the y-intercept, we pretend that x is 0. Well, that gives us 4y equals 12. All we have to do is divide by 4, and we get y equals 3. So our y-intercept should be written 0, 3. That's our y-intercept. That's the proper notation for intercepts. Same basic rules for this one. I know this equation looks more difficult, but it's the same basic rule. So the x-intercept is we pretend that the y term is gone. Okay, so we have 3x minus 5 equals 4. We add 5 to both sides. We get 3x equals 9. Divide by 3 gives us 3. Our x-intercept would be 3, 0. Okay, so on a test, even if we were in regular class, I would mark that wrong. If you just wrote x equals 3, that's not the proper notation. Okay, 0, 3 is the x-intercept because it is a point on the graph. It should be written as an ordered pair. So to find the y-intercept, now we get rid of our x value. All right, we pretend x is gone, x is 0. So we end up with this equation with just a y in it. So we add 5 to both sides and we get y equals 9 halves. Or you can write 4.5, that's fine. So there we go, 0, 9 halves. All right, so the next thing is a formula, a distance formula. And there's different versions of this, so the video maybe had a different version, I don't know. x2 minus x1 squared plus y2 minus y1 squared. And I know it doesn't look like it, but that's actually a weird form of the Pythagorean theorem. Okay, so let's take A and C from our previous problem. Okay, point A and point C. So point A from above and point C from above. Well, point A was 3, -2. Point C was -4, 5. And we're just going to fill that in. Now, this is where, if you're new to this, it's okay to label. This is x1, y1. That's just our first point. x2, y2. So those little 2's are there just to say, hey, that's our second point, just sort of as labels. So the x's, we have -4 minus 3 and squared. And the y's, we have a 5 minus -2 and then squared. So that's going to give us a -7 squared plus a 7 squared. Well, that's going to be 49 plus 49, which is the square root of 98. So in class, I would say, yeah, I would accept that. I certainly would. I would even accept the decimal version of that. It'd be 9 point something. You know, I would accept that also. My math lab might be a little pickier. They might ask you to reduce this. So this would be 2 times the square root of 49, which would reduce down to 7 times the square root of 2, would be technically the best reduced mathematical answer. But I'm not sure how picky my math lab will be on that one. So you could certainly use a calculator and write decimals, generally speaking. A lot of your calculators will reduce that for you as well. All right, so here's one I didn't fill in the points. So let's just give you point A, let's say is 1/2, 3/4. And let's say point B is 1/4, comma, negative 1/8. Because some of your assignment problems do have fractions in them, possibly. So the process is the same. I'm not going to rewrite that formula. Okay, you just need to subtract the x's, subtract the y's. And so this one, it's okay to use a calculator, I guess is what I'm trying to say. At a certain point, I get lazy and I would prefer to use a calculator as well, but fractions do come up sometimes. You got to get used to them. So in order to add, subtract fractions, you need a common denominator. Well, on this first one, the common denominator is going to be 4. So this is the same as 1/4 minus 2/4. Well, that gives us negative 1/4 squared. Negative 1/4 squared is going to be 1/16. This one, this other parenthesis under the radical, the common denominator is going to be an 8, obviously. So I'm going to times both of these by 2 over here, so it's going to be 6/8. Well, that gives us negative 7/8 squared. Well, squaring that's going to be 49 over 64. And this is where I would get lazy, and I would just grab a calculator. Okay, if you want to keep doing fractions, that's fine. Now we have to have another common denominator. Well, luckily I didn't make it too difficult. This is going to be a common denominator of 64. So it's going to be 4/64 plus 49/64. That adds up to the square root of 53/64. And we could keep reducing that. Again, I would just use a calculator. You can use the calculator in fraction mode if you need to, but one thing to make a note of, another way to ask that is this. They could say find AB with this little line above it. That's just another way of saying find the distance from A to B. The last little thing here is a midpoint formula. A midpoint formula may look worse, but it's actually easier. Midpoint formula looks like this: x1 plus x2 over 2, comma, y1 plus y2 over 2. So let's find the midpoint. Let's say I give you point B. I'll just make these up. 2, negative 7, and point C, let's say, is negative 8, comma 1. All you have to do to do the midpoint is add the x values, divide by 2, add the y values, divide by 2. Okay, basically you're finding the average. So our midpoint here is going to be negative 6 divided by 2, negative 6 divided by 2. I did not do that on purpose. So it's going to be negative 3, comma, negative 3. Okay. The last example I have here is another midpoint, but I just want to warn you, sometimes you'll be given decimals. 2.1, comma, 4.23. And let's say point B is negative 0. We'll say 9.4, comma, negative 8.47. Okay, the process is the same. All you need to do is add the x values and divide by 2. So I'm going to grab a calculator and add those, and then push equals and divide by 2. I'm going to grab my calculator. But if you take 2.1 minus 0.94 and then divide that by 2, we get 0.58. And the other one, 4.23 plus a negative 8.47, That gives us negative 4.24. Divide that by 2. That gives us negative 2.12. That would be our midpoint for that one. And that's it for my examples for 1.1.